Hello, today we will look at applications of right triangles. Let's get started. So all you have to do is you have to remember how right triangles work. So how do you know something is a right triangle? They'll tell you, okay, and they'll put a little notch in there showing that it's 90 degrees. If you label this ABC and you label this theta, you know a couple of things about this. A squared plus B squared equals C squared. And the basic three, which is sine theta, opposite over hypotenuse, cosine theta, adjacent over hypotenuse, tangent theta, opposite over adjacent. You can actually solve almost all problems with this. You don't have to go to secant, cotangent, and cosecant. So now let's talk about an application, and that's the angle of depression or elevation. Okay. So an angle of depression, so when you're sitting down, usually they will just tell you, you're sitting down, you're standing up, and here's your eye. And then you go to your eye level, and they will tell you eye level or something about it. And you're looking or something that is higher. And there will be a degree, an elevation or radian over the horizontal. And this is your line of sight. And this one is going to be angle of elevation. Okay, now let's look at some like that. So you are sitting down. Here's your eye. And there's an object there. And you're looking down. This one is angle of depression. It's not like depression, sadness. And this one is horizontal. And here's your line of sight. All right, now let's have an application of that. So you have a situation where you're on top of a building. Here are the windows. And you're on top of it. And then you're here. And then you're looking at the Empire State Building. Yeah, that one is tall. All right? And then you're just looking at the tip of it or something. So you're here. And here's your horizontal. Your height is actually so insignificant compared to those buildings. We ignore it. I mean, if you want to be really, really accurate, you can add your height. But this is what you have. You realize, you measure, you can actually do that with some civil engineering methods. 48 degrees. And you know that this is 80 feet, that building that you're standing on. And you know that the two buildings are 1,237 feet apart. All right. What you want to know is what is the height of the Empire State Building. Okay, now let's go, we are talking about line of sight of elevation at this point. So I'm looking at it. So let's look at tangent 48. That's going to be opposite over hypotenuse, opposite over adjacent. We are looking at this triangle here. Let's call this A. So I know this is going to be opposite over adjacent. And then when you plug that in, you're going to get A equals tangent 48 times 1237. So let me go get my handy dandy calculator. It's coming. Let's turn this off. And let's clear all this so I start easy. Let me check my mode. I always check my mode. It's in degree right here. I'm wiggling. Get out of that mode. So it is tangent of 48 times 1237. That gives me 13, what was it? 1373.8. That's about 1374. And my unit is in feet. And what do I need to add to it? I need to add the 80 feet that the other building is incorporating. So it's going to be 1374 plus 80. You just add those. You get about 1454 feet. Alright, so this is an application of that. There will be a video that has bearing, but I'm going to introduce the concept of bearing here because it is used in navigation in a lot of areas. And so you have to watch the other video as well, but I will just do some bearing things here as well because it applies, it's related to right triangles. So let's talk about bearing. Now, direction of one point from another, that's a bearing. And you use that in navigation, ships traveling and how that works. You need to know how the north, south, east, west works. And this is the convention. This is your north. This is your south. This is your east. This is your west. A bearing can be, let's say I'm looking at the bearing of point A. It is you have to always measure from the north or south. That's one way, from north or south. And in the bearing video, you'll see that you can also do it other ways, but one way to determine bearing is north and south. And if you're doing it from the north, and this one is, let's say, 50 degrees, how did you go? You started with north, you went 50 degrees, and which way towards which direction did you go? East. So when you do it this way, you have to put north, south, or whatever that you're doing. So this one is north 50 east, and that's what it means. So let's do a couple of those so that you kind of get a feel for it. Again, let's say I'm here, I'm going this way, and this is 40 degrees. This is still north, and this is now west. So how can I write that? I start where I'm north, I go 40 degrees, I'm going towards west. Alright, that makes sense. Let's do another one here. Let's go this way. Let's say I went 35 degrees that way. And so this is north, south, east, west. So where did I start? I started south. I went 35 degrees. I went towards west. Cool. And let's do another one right here. Again, east, west, north, south. I'm going to go, did I do this quadrant? No. Okay, let's say this one is 30 degrees. So where did I start? South. I went 30 degrees and I went towards east. Okay, So now that I know how this works, I'm going to give you a problem. A cruise ship travels from A to B on a bearing, here we go, is the word, south 15 degree east. Alright, I draw a picture right away. Oops, I'm not very good at this. East, west, north, south. I start from A, and I'm going south 15 east. Here's my 15. And I'm going towards, here's my B. Very good. Alright, here's the, they will say, Miss, for example, how many miles did the ship travel south? Okay. Now, I need one more piece of information. After that ship traveled, how far apart is this, A and B? Let's say this is given. Let's say 150 miles. How far did it travel south? So this is what they're asking. They are simply asking why. And as you see, this is a right triangle. So what can you write? You can write cosine of 15 degrees is simply adjacent over hypotenuse. And y is going to be cosine 15 times 150. Alright, let's get our handy dandy calculator. Make sure you are in degrees. Yes, I am. So cosine of 15 times 150. It is 144.9, about 145 miles south. And this concludes a few applications of right triangles. And it's pretty simple. Just make sure that you pay attention to the words and double check your answer. Does this make sense? It went 145 miles south and it was 150. 150 is longer. Yeah, it makes sense.